The next type of conic that we're going to discuss is called the hyperbola. The hyperbola basically looks like two parabolas that are pointing away from each other. Like the ellipse and the circle, they have a center. The center of a hyperbola is going to be equidistant from what we would consider to be the vertices of these parabola shapes. The distance from the center to the vertex is going to be a units long. But in order to draw these parabola shapes, we're going to draw some asymptotes on the graph. Remember, an asymptote was a line that the graph gets closer and closer to, but it never actually touches or crosses. And so in order to find those asymptotes, we're going to draw ourselves a box in the middle of the hyperbola. So like with an ellipse, when we went A units one way and another way, and then we went B units another way and another way, we had drawn an ellipse. Instead of drawing that ellipse, we're going to make ourselves a box. The diagonals of that box are going to be the asymptotes that the hyperbola gets closer and closer to. There are two different types of hyperbola that we're going to discuss. We're going to discuss the hyperbola that opens up and down, and the hyperbola that opens left and right. If the hyperbola opens left and right, its equation is going to be x minus h squared over a squared minus y minus k squared over b squared equals 1. The only difference between this equation and the equation of the ellipse is that minus sign in the middle. So that's how you're going to know which type of conic you're dealing with. However, if the parabola shapes open up and down, then the equation is going to be y minus k squared over a squared minus x minus h squared over b squared equals 1. By definition, a hyperbola is a set of all points in a plane in which the difference of two distances from two distinct fixed points, called the foci, are constant. For an ellipse, that was a set of all points where the sum of the distances between the foci and some point on the ellipse, their sum was always the same. This one, it's going to be the difference is always the same. The set of definitions for the two hyperbolas are in your formula packet or on the front page of the notes. On an ellipse, the two axes were known as the major axis and the minor axis. For hyperbola, we're instead going to call them the transverse axis and the conjugate axis. Those are going to be the two lines that are going to create our box between the hyperbola. The transverse axis is always the distance between the two vertices. We're going to call that 2a. The perpendicular axis to the transverse axis is going to be called the conjugate axis, and it's going to be length 2b. So, in example 1, I want to find the center, foci, and vertices, as well as the slopes of the asymptotes of the hyperbola x minus 5 squared over 25 minus y plus 1 squared over 9 equals 1. The center works like it does for a center in a circle or ellipse. Okay, the center is always at hk. So in this problem, hk is going to be 5, negative 1. Remember, if you don't remember what h and k are, set the parentheses equal to 0 and solve for each variable, and that's how you're going to determine h and k. So now I'm going to graph 5, negative 1. 1, 2, 3, 4, 5, negative 1. There's my center. Next, I need to determine how the hyperbola opens. Because x comes first, the hyperbola is going to open left and right. So 25 is a squared, so a is 5. So I'm going to go 1, 2, 3, 4, 5 units to the right of center and 1, 2, 3, 4, 5 units to the left. Those are going to be my vertices of my hyperbolas. And my hyperbolas, they're going to open like this, but we're going to draw something more specific in a minute. So I'm going to get rid of those lines. So this must be b squared, which means that there's a point 1, 2, 3 units above center and 3 units below. Here's my box. The diagonals of that box are the asymptotes. If you look at the definitions, we only care about the slopes of the asymptotes. The slopes of the asymptotes, if the hyperbola opens to the left and to the right, are going to be plus or minus b over a. So it's plus or minus 3 over 5. So if you check this out, if you start at center and you go up 3 and to the right 5, that's the next point on your asymptote, because that's the slope, rise over run. And then here are my asymptotes. Sorry, here are my curves. This should touch the vertex. And so this gives us a nice, pretty accurate drawing of the hyperbola. So we found the center. The vertices, I didn't really say where they were. We can see in the pictures that the vertices are at 10, -1, and 0, -1. So now I know the vertices. And they also want us to find the slopes of the asymptotes. And they want us to find the foci. All right, let's talk about the foci. The foci will always be inside the little parabola shapes. When the hyperbola opens left and right, the foci are going to be at h plus or minus c comma k. But this time, the definition for finding c is a little bit different. It's b squared is equal to c squared minus a squared. So b squared was 9, and a squared was 25. And so I'm going to have to add 25. So I get 34c squared. So c is the square root of 34. So the foci must be at 5 plus or minus the square root of 34, comma, -1. Now let's talk about a problem where I give you the graph and we want to extrapolate information from the graph to write the equation. So the first thing I want you to notice is that the hyperbolas open left and right. So they're over here and here. So I know that the equation is going to be x minus h squared over a squared minus y minus k squared over b squared equals 1. I need to know 3 pieces of information. I need to know the center, I need to know A, and I need to know B. So let's start with the center. The center appears to be at 2, -3. So now I know what h and k are. So h is 2, and k is -3, which means this is going to become +3. A is the distance from the center to either vertex. So if the center is at 2, and the vertex appears to be at -2, that's 4 units. Or you could have gone the other direction. If you had started here at 2, this vertex appears to be at 6, you would have gone 4 units. So if A is 4, then A squared is 16. B is going to be the distance from the center to either the top or the bottom of the box. So the center here is at the y value is -3, and up here the y value is 2. That's 5 units long. Or from -3 to -8, also 5 units. So b squared will be 25. And that's the equation of the hyperbola. This is a special type of hyperbola. We've actually talked about this equation before. You've probably forgotten though. xy equals 49. If I solve that equation for y, I get 49 if you go back into your calculator and you graph the parent function is 1 over x. And the graph of 1 over x looks like this. We call those two curves hyperbola. And the asymptotes were the y-axis and the x-axis. So, any equation in this format is going to be hyperbola in 2 quadrants. Here's the rule. Y equals positive, we'll call it a over x, is going to be hyperbola in quadrants 1 and 3. However, if the equation is a negative constant over x, the hyperbola will be in quadrants 2 and 4. So this is positive 49 over x. What's the graph going to look like? Well, we need to figure out where the vertices are going to be. And I guess I should go back because I guess we call this K. I mean, it's been a while since I've taught it, so I'm trying to go back and remember what we called this. The vertices, if it opens in quadrants 1 and 3, are going to be at square root of K, negative square root of K, negative square root of K. So for this particular problem, the vertices are going to be at 7, 7, and negative 7, negative 7. So 1, 2, 3, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. So it's going to be here. So the curve is going to look like this. The other vertices are going to be at negative 7, negative 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It's going to be here, and the curve is going to look like this. However, if you had been given negative k over x, like, for example, let's say you'd been given y equals negative 3 over x, the vertices, because they're in quadrants 2 and 4, would be at square root of k, negative square root of k, and negative square root of k, positive square root of k. Just like with circles and ellipses, we have an expanded form of the equation. This is the expanded form for the hyperbola. It looks just like the equation for the ellipse, except for one simple fact. These two coefficients will be opposite signs. So one of them will be positive and one of them will be negative. For an ellipse, they're both positive. But for a hyperbola, one of them will be positive, one will be negative. We're going to go about completing the square in the same fashion. So if you had trouble completing the square with circles or ellipses, we're going to do it again. So in problem 4, let's write 4x squared minus y squared plus 24x plus 4y plus 20 equals 0 in standard form. So we write the x's together in their own parentheses. We put the y's together in their own parentheses, and I want you to notice that I started with a plus sign here. It will go away, but make sure that you see that y squared is negative. The constant gets moved to the other side, so it's going to become negative. We had said that we can't complete the square unless the leading coefficient is 1. So whatever the coefficient is in front of the square term gets factored out. So when you divide by 4, you get x squared plus 6x plus blank. The coefficient here is negative 1, so you're going to factor out a negative 1. That means you're going to get y squared minus 4y. And the reason that this is still going to be a positive is because in a perfect square trinomial, the last term is always a number times itself. Positive times a positive is a positive. A negative times a negative is a positive. So that will always be positive, even if when you divide, the middle term changes sign. Now we're going to complete the square. The first parenthesis is 9 because 6 divided by 2 is 3, 3 squared is 9. The second parenthesis is 4. Negative 4 divided by 2 is negative 2, negative 2 squared is 4. To find the numbers that go on the other side, you multiply these together. So 4 times 9 is 36. Negative 1 times 4 is negative 4. Now I'm going to go write these in factor form. So I'm going to get x plus 3 squared minus 1, y minus 2 squared equals 4. And then the last step, we want the equation to equal 1, so we're going to divide both of them by 4. So I get x plus 3 squared over 1 minus y minus 2 squared over 4 equals 1. So now I can tell you that the center is at negative 3, 2. I can tell you that after you graph that, I'm just graphing it for the purpose of showing you what's going on. Here's negative 3, 2. There's the center. I can tell you that this parabola opens left and right because x comes first. It has nothing to do with the bigger number. That's with an ellipse. With hyperbola, whichever variable comes first is going to tell you how it opens. So if x comes first, it's left and right. If y comes first, it's up and down. So I can tell you that the vertices are going to be 1 unit to the left and to the right of center. Since this is b squared, this is a squared always comes first, and b squared is 4, so b is 2. Here's my box. Here's my asymptotes. Their slopes are going to be plus or minus b over a, so plus or minus 2 over 1. And the hyperbola will look like this. They'll be really wide. Last problem, number 5. Find the equation of the hyperbola with foci at 1, negative 5, and 1, 1, and whose transverse axis is 4 units long. So I had said that when you have a problem like this and you want to write the equation, you need to know how it opens. Sometimes in order to figure out how it opens, we draw ourselves a little picture. So the foci are at 1, negative 5, and 1, 1. The foci are always inside the parabola shapes that make up the hyperbola. That means my hyperbola must open up and down. So the equation is y minus k squared over a squared minus x minus h squared over b squared equals 1. So we need to find the center, A and B. The center is easy. The center is the midpoint of the foci. So if you draw a picture, you might be able to tell where the midpoint's going to be. It should be here at 1, negative 2. But if you don't see that, you can always do the midpoint formula. Add the x's, divide by 2. Add the y's, divide by 2. And you're still going to get 1, negative 2. So I know that h is 1. And I know k is negative 2, which means this is going to become plus 2. The other piece of information they gave me was the transverse axis is 4 units long. The transverse axis is always 2a, so if 2a equals 4, then a must be 2. So a squared is 4. To find b squared, they told me where the foci were. The foci are always c units from the center, so c must be 3. We're going to use b squared is equal to c squared minus a squared to find b squared. So b squared is 9 minus 4. So b squared is 5. And all I have to do is erase that and put a 5. And there's the equation of my hyperbola. So you can work on the assignment for 10-4 if you'd like. If you want to work on finishing the problems from 10-3 day 2, that's preferable. Work on your completing the square to write in the format that tells us the center and the vertices. And work on these problems like number 5 here, where they give you information for finding the equation of a hyperbola or of an ellipse. And we will finish off these problems on Monday.